Before we move on to how linear equations are plotted on the coordinate plane, let's quickly review what linear equations in two variables are. We've seen equations like 2x plus 5y equals 12 or x minus y equals 4 and so on. These are examples of linear equations in two variables. Each of the equations has two variables x and y. But how do we generalize it? How can we define it? We can say that a linear equation in two variables is of the form ax plus by equals c, or sometimes it's also written as ax plus by plus c equals 0. Both are correct. For example, the first equation can also be written as 2x plus 5y minus 12 equals 0. For this video and the future ones in this topic, we will assume the second one to be the general equation for linear equations in two variables. Ax plus by plus c equals 0. A, b and c are constants, while x and y are variables. A is the coefficient of x and b is the coefficient of y. This is the general form we will consider. Hold on, are there any conditions here? Yes. First, the constants a, b and c have to be real numbers. And the second condition is interesting and I want you to listen to it carefully. Both a and b cannot be 0 together. Yes, it means at least one has to be non-zero. Can you come up with a mathematical way to write the second condition? It's interesting and a very innovative way to write it. It can be written as a squared plus b squared will not equal 0. This will imply that both cannot be 0 together. Because if both are 0, then the left-hand side will equal 0. Now let's just consider the first equation we saw. 2x plus 5y equals 12. What is the solution to this equation? The solution to a linear equation in two variables is a pair of values. One for x and the other for y, which makes both the sides of the equation equal. Can you think of x and y values here which will equate both the sides? One possibility is when x is 1 and y is 2. So we can say that x equals 1 and y equals 2 is one of the solutions to the equation 2x plus 5y equals 12. Can you tell me if x equals 3 and y equals 1 is the solution to this equation? The answer is no. If we substitute these values on the left-hand side, we get a value of 11 which is not equal to 12. So this pair of values is not a solution to this equation. Now that we have a basic idea about linear equations in two variables, we can move on to looking at pairs of linear equations in two variables.
plus y, x plus y equals 5. So it's a very, very simple equation. And all we want to do is look at these ordered pairs that we're given. The first one is 3, 2, and we want to see if it's a solution to the equation. So the 3 here is our x value, right? That's the first value, the value to the left. The 2 here is the y value, okay? That's the value to the right, okay? So it's x value, comma, y value. So all we're going to do is we're going to plug a 3 in for x, so plug a 3 in there, and we're going to plug a 2 in for y, so plug a 2 in there. And obviously 3 plus 2 is 5. So that's pretty simple, right? 5 equals 5. Yeah, this is a true statement. So we can say that this ordered pair 3, 2 is a solution to that equation. X plus y equals 5. Okay, let's look at the next one. And again, the equation is x plus y equals 5. So we have an ordered pair here, 8, negative 3. So again, 8 is the x value, negative 3 is the y value. So I'm plugging in an 8 for x there, plugging in a negative 3 for y there. So what's 8 plus negative 3? Well, that equals 5 as well, right? So yes, this ordered pair is a solution. Let's look at the next one. And again, I'll just keep rewriting the equation so we don't have to keep scrolling up and down. X plus y equals 5. So we have the ordered pair negative 6, 7. Again, this is the x value. This is the y value. So I'll have negative 6 plus 7 equals 5. Negative 6 plus 7 is 1, and that is not equal to 5. So this is not a true statement here. So that means this ordered pair is not a solution. Okay, let's look at a more difficult equation. Here we have 7x minus 5y equals 20, and we're given an ordered pair of 0, 4. So again, nothing changes. This 0 is our x value. This 4 is our y value. So I'm plugging in a 0 for x, so 7 times 0. I'm plugging in a 4 for y, so minus 5 times 4. That will go away. 7 times 0 is 0. I'm left with negative 5 times 4, that's negative 20. And that is not equal to 20. So no, this is not a solution. Okay, so we have 5, 3 now. Let me just rewrite the equation real quick again so we don't have to keep scrolling back and forth. So 7x minus 5y equals 20. And again, our ordered pair is 5, 3. So 5, again, is the x value. 3 is the y value. So I'm going to plug a 5 in here, and I'm going to plug a 3 in here. So 7 times 5 minus 5 times 3 equals 20. 7 times 5 is 35. 5 times 3 is 15. This is going to be true, right? 35 minus 15 is 20. So we have a true statement here, so we can say yes, this ordered pair is a solution to our given equation, 7x minus 5y equals 20. Okay, here we have negative 10, negative 18 is our ordered pair. And again, the equation is the same. 7x minus 5y equals 20. So I'm plugging in a negative 10 for x here, right? Negative 10 is my x value. And I'm plugging in a negative 18 for y here. Right? Negative 18 is my y value. So we would have 7 times negative 10 minus 5 times negative 18. And this should be equal to 20 if this ordered pair is a solution. So 7 times negative 10 is negative 70. And then negative 5 times negative 18 would be 90. And we can see that this equals 20, right? Negative 70 plus 90 is 20. So we have a true statement here, and we can say that our ordered pair, negative 10, negative 18, is a solution to this equation. Okay, so if we choose a number for one variable, we can find the other value that makes the equation true. Okay, so we're going to have to do a little work with solving some equations here. So we want to complete each table of values for the following equations. The first one we're going to start out with is 2x plus 5y equals 10. So this is going to help you a lot when you start graphing equations. So we have, again, 2x plus 5y equals 10. And all this is of giving you an x value here of negative 5. What you have to do is you have to find the corresponding y value that makes the equation true. So what we do is we plug a -5 in for x, so you'd have 2 times -5 plus 5y equals 10. So 2 times -5 is -10. And now you just treat this as a linear equation in one variable, and you just solve for y. So if I add 10 to both sides of the equation, that becomes 0. I'm left with 5y equals 10 plus 10, which is 20. Then I can divide both sides of the equation by 5. That will cancel, become 1, and I'll have y equals 20 divided by 5, which is 4. So the ordered pair here would be -5, 4. So just in my table format, I have an x value of -5, a y value of 4. So again, this is going to be -5, 4 as an ordered pair. Okay, next let's look at this value that you're given here, which is 0. So if I have an x value of 0, we would have 2 times 0 plus 5y equals 10. 2 times 0 is 0, so you're just left with 5y equals 10. And you can solve that by inspection. You know the answer is 2. But we'll go ahead and just divide both sides of the equation by 5. And again, you get y equals 2 as your answer. Okay, so that would be another order pair that we'd have. And I'll write that as 0, 2. Now, if we move down, I've given you some y values. I've given you a y value of -2. We need to find a corresponding x value that makes the equation a true statement. So if I plug a -2 in for y now, so you'll have 2x plus 5 times -2, plug a -2 in for y, equals 10. You'd have 2x plus or minus 5 times -2 is -10, so minus 10 equals 10. Okay, so again, we just have a linear equation in one variable. We just solve for x. So add 10 to both sides of the equation. That's gone. You'll have 2x equals 20. Divide both sides of the equation by 2. And you'll have x equals 10. Okay, so this will be a 10 over here. All right, so we have another ordered pair. It would be 10, -2. Okay, and then we have one more. I've given you one last y value here of -4. So again, just plug a -4 in for y. So 2x plus 5 times -4 equals 10. 5 times -4 is -20, so you have 2x minus 20 equals 10. And then we just solve this for x. So add 20 to both sides of the equation. And you're going to have 2x equals 30. Divide both sides of the equation by 2. And we're going to end up with x equals 15. Okay, so we'll put a 15. So then my last ordered pair would be 15, -4. So you could continue to do this forever. You can pick an x value and then solve for the corresponding y value that makes the equation true. You can pick a y value and solve for the corresponding x value that makes the equation true. And again, there's going to be an infinite number of these solutions that you can get.